Example number 1, called working off breakfast. So this is an example to get you familiarized with using the mechanical equivalent of heat. All right, so we have a student who eats his breakfast, bowl of cereal, and we're told that well, I guess we'll write down the given here. We're told that the total amount of energy that he consumes, we'll call that, I guess, E, is 3.2 to the power of 2 calories. That's his food calories, right? And he wishes to you take all this energy that he consumed and do some work, right? He lifts a barbell with a mass of 25 kilograms, and he moves it at a vertical height of 0.4 meters. Assume he's on Earth, and the acceleration due to gravity is 9.8 newtons per kilogram. So what we're trying to find is the number of times he raises this, right? I'll just call it N. Okay? So this question is really kind of getting you used to converting, I guess, a bit of units. We have to convert the 3.2 times 10 to the power 2 calories. Oops, that's a calorie here. To joules, because we have mass in kilograms and height in meters and gravity in newtons per kilogram, so that's going to be calculated in joules, right? So we need to convert food calories into basically joules of energy. All right? So just looking a little bit above here, you'll see that a calorie here is 4.186 joules, but that's not a food calorie. By the way, a food calorie, which we use like a capital C instead of small c here, is really equal to 1,000 little calories here. All right, so if 1 calorie is 4.186 joules, 1 food calorie is essentially 4,186 joules. Okay, so we're going to use this guy, right, to do our conversion. We need to change this to joules. So we multiply by 4,186 joules per food calorie, right? The calories cancel out, right? And then we get our answer in joules. So our energy is 1.3389, if you want to keep all the digits, times 10 to the power of 7 joules. Okay, now, one repetition, right? Let's say he lifts up mass one time, right? The change in potential energy is just mgh, if you recall. But of course, we want the total amount of energy, so we're going to multiply by the number of times that he does that, right? So you can think of it as that total change in potential energy is going to be 25 kilograms times 9.8 newtons per kilogram times h, which is 0.4 meters, and then n. I don't know how many times. That's what we're looking for. So this gives us 98 joules multiplied by n, right? So now it's just really, we're going to assume that the food energy he's consumed is equivalent to the total potential energy that he's using. So we equate these essentially equal to each other. The energy is equal to the gravitational potential energy. So 98, let's leave off the units for now, n, because they're going to be joules anyway. I guess we can put the joules, well, we'll leave the joules in there because we want to make mistakes with our units, right? Joules. And that's n for number of times. And then that's equal to 1.3389 to the power of 7 joules. Of course, the joules cancel here, and so we end up with a unitless quantity. And then now we are just taking the ratio of 1.3389 to the power of 7 joules all over 98 joules. I don't get the right answer that I'm listed down here. And I'm thinking about it and wondering where I went wrong, and now I realize it, that the guy who's doing exercise has to not only lift the bar up, but has to bring it back down. So really the amount of work that he's doing is actually twice this. So we need to essentially multiply this answer by 2 in here. So this makes this multiply by 2, and this changes this answer here to 196 joules multiplied by n. All right, and that changes this to 196 joules. And so then therefore I'm really got a factor of 2 in the bottom, which then now when I put that answer in there, I do indeed get my answer that I initially had, which is 6.84 to the power of 3 times. Okay, I hope that makes sense. Thank you.